day everyone! Welcome to Math with Teacher Justin. On today's topic, we're going to talk about solving systems of linear equation using substitution method. Alright, let's talk about solutions of a systems of linear equation. Now, a solution of a system of linear equation is an ordered pair that satisfies all the equations in the given system. If we're going to graph that, it is the point of intersection of our linear equations in the system. So that's the purple dot in our graph. Or in solving systems of linear equation, we can use substitution method in getting our solution. So here are the steps in solving systems of linear equation using substitution method. So in this method, transitive property is applied to solve the systems of linear equation. Now, first step is to solve one of the equation for one variable. So we're going to choose one equation and we're going to isolate one of the variable of that equation. Then, step 2, we will substitute the value or the temporary value of that variable to our other equation. And third step, we will now solve for the remaining variable. Now that we have our value of that remaining variable, we're going to substitute that value of that variable to either the first or the second equation. Ayan. And fifth step, solve for the remaining variable. And last one is to check the proposed solution in our original equations. Now let's have some examples in solving systems of linear equation using substitution method. Okay, let's have an example. For example, we're going to solve this system of linear equation. So we're given two equations. We have x minus 3y is equal to negative 20 and y is equal to x plus 12. Now let's observe our equation. Now, our first equation is written in standard form and our second equation is written in slope-intercept form. Now, knowing that our second equation already isolated one of the variables, we will now proceed to our next step. We will use our second equation, the value of y being equal to x plus 12, and substitute that to our first equation. So we copy our first equation and replace the value of y being equal to x plus 12. So replacing y with the value of y for our second equation. So we will have x minus 3 times the quantity of x plus 12 is equal to negative 20. Now let's apply distributive property. We will have x minus 3x minus 36 is equal to negative 20. If you can observe, we only have one variable in this equation. Therefore, we can now solve for the value of that variable. In this case, we solve for the value of x. So let's solve by combining like terms. We will have negative 2x minus 36 is equal to negative 20. Then transfer negative 36 to the other side of the equation, combine like terms. So we will have negative 2x is equal to 16. Let's solve for x by dividing both sides by negative 2. Now, x will be equal to negative 8. Now that we have one of the values of our variable, which is x is equal to negative 8, we can either use or substitute this value to either first equation or second equation. So for me, I prefer to use the second equation because y is already isolated. So when I substitute negative 8 to the value of x, I will get the value of y. Okay, so let's substitute the value of x, which is negative 8, to our second equation. So y is equal to negative 8 plus 12. Combining like terms, the value of y is equal to 4. Now that we have our values of x and y, it's time for us to double check if this is the true solution in our given system. So we will test them by substituting both variables or both values to our original equations. Let's start first with our first equation. Let's substitute negative 8 and 4. Then combine like terms. We will end up with negative 20 is equal to negative 20. So it satisfies our first equation. What about our second equation? So let's substitute, then combine like terms. We will have 4 is equal to 4. So it also satisfied our second equation. Since it satisfies our first and second equation, we can now conclude that our solution for this system will be negative 8, comma 4. Okay. Let's have another example. So for example, we're going to solve the system of this linear equations. So in this system, we're given two equations. We have x plus 2y is equal to 11 and 3x minus 2y is equal to 9. Now our first step is for us to pick an equation, and we're going to isolate one of the variables. Now, I suggest I'm going to give you a tip in identifying what equation to pick. Choose an equation having a variable with a numerical coefficient that is equal to 1. So, looking at our equation, we have our variable having that numerical coefficient that is equal to 1, and that is from our first equation. Now, let's isolate that variable. So we have x is equal to negative 2y plus 11. So we just transfer positive 2y to the other side of the equation and changing its sign. Now that we have our variable that is isolated, we will now use our second equation and replace that variable x with negative 2y plus 11. So substituting, we will have 3 times the quantity of negative 2y plus 11 minus 2y is equal to 9. Then, let's apply distributive property. So, we will have negative 6y plus 33 minus 2y is equal to 9. Let's combine like terms. We will have negative 8y plus 33 is equal to 9. Now, if you can observe, we only have one variable. So, we can now get the value of that variable. So, let's transfer positive 33 to the other side of the equation. We have negative 8y is equal to 9 minus 33. Then, combine like terms, we have negative 8y is equal to negative 24. Let's divide both sides by negative 8. Our y will be equal to 3. Now that we have our value of y, we can now use this in getting the value of our variable x. Okay, we can either substitute y to our first equation, second equation, or to our isolated value of x of our first equation. So for me, I will use the isolated value of x already, because if we substitute the value of y, we simplify it, we will get the value of x without transposing or transferring other terms. Okay, so let's substitute y. We will have negative 2 times 3 plus 11. Simplifying and combining like terms, our x will be equal to 5. Now that we have our values of x and y, it is necessary for us to double check if our solution is correct. So we apply our last step, which is checking. So we substitute the values of x and y to our original equation and check if we will have and check if they will satisfy both equation. So let's test our first equation and substitute the values of x and y. Let's simplify. We will have 11 is equal to 11. So it satisfies our first equation. What about our second equation? Let's substitute our x and y to this. So simplify and then combine like terms. We will have 9 is equal to 9. So it also satisfies our second equation. Therefore, we can now conclude that our solution or the point of intersection of these two linear equation will be at 5, 3. Alright, okay, let's have our last example for today. So for example, we're going to solve the systems of linear equation. So in this system of linear equation, we're given two equations, which is 4x minus 5y is equal to 4 and negative 6x plus y is equal to 20. So first step is for us to pick an equation that we're going to isolate one of the variable. So like I suggested before, we're going to pick an equation with a variable with a numerical coefficient that is equal to 1. It will make it easier. So in this system of linear equation, our second equation has that variable that has a numerical coefficient that is equal to 1. So we will isolate that variable y by transferring negative 6x to the other side of the equation. So we will have y is equal to 6x plus 20. Okay, so after that, we know that our value of y will be equal to 6x plus 20. So we will use 6x plus 20 as a temporary value of our y. So next, let's proceed to our second step. Okay, we will use the other equation, which is 4x minus 5y is equal to 4, and replace the value of y, that is 6x plus 20. So you apply substitution method. So we will have 4x minus 5 times the quantity of 6x plus 20. It is equal to 4. Then, let's apply distributive property. We will have 4x minus 30x minus 100 is equal to 4. Then, combine like terms. So, we have negative 26x minus 100 is equal to 4. Now, let's isolate our variable by transferring negative 100 to the other side of the equation. So, we transpose, we change the sign. So, we have negative 26x is equal to 4 plus 100. Let's combine like terms. We have negative 26x is equal to 104. Then from there, let's divide both sides by negative 26. So 104 divided by negative 26, we have x is equal to negative 4. So now that we have our value of x, we can now use that in order for us to solve for the value of y. Now, we can either substitute the value of x to our first equation or second equation, or the isolated form of our second equation. So for me, I will use the isolated variable y equation of our second equation, because y is already isolated. When we substitute negative 4 to the value of x, no need for us to transpose or to apply addition property or subtraction property to isolate one of the variables. Let's substitute negative 4 to the value of x, and simplifying it, then combine like terms, we will have the value of y that is equal to negative 4. Now that we have our values of x and values of y, we can now apply checking. It is always important for us to check if our solution or proposed solution will satisfy our first equation and second equation. Okay, so let's apply checking. Let's check if negative 4 and negative 4 will be our solution. So let's substitute that to our first equation. Simplifying it, we will have 4 is equal to 4. So it satisfies our first equation. Now let's check our second equation. So negative 6x plus y is equal to 20. Let's replace our x and y with negative 4. So simplifying that, we will end up with 20 is equal to 20. Since it satisfies both equations, we can now conclude that our point of intersection, our solution, will be at negative 4, negative 4. Alright, now that you already know how to solve systems of linear equation using substitution method, it is your turn to try it. Please click the link in our description box below in order for you to test your skills. That's it for today. Again, I'm Teacher Justin. Goodbye, God bless, and stay safe. See you on my next video. Peace.